In today's lesson, we will be analyzing and sketching story graphs. In this lesson, we will analyze the relationship between two quantities using graphs, and we'll sketch graphs to represent the relationship between two quantities. So a graph can show the relationship between quantities without using specific numbers on the axes. For example, in this one, we have time, and it's increasing going to the right, and distance is increasing as it's going up. So if I'm looking at time versus distance, I can see that I am increasing at a steady, constant rate, so a constant rate of change. And here I have no rate of change. See, my distance is at the same height, so there's no change in my distance. This would be like staying at maybe like a bus stop or something like that, where you are not changing where you are at, but time changes. You have to wait for that bus. And then it is this is decreasing, so the distance is decreasing, but it's also at a steady rate. You should notice the incline of this and this one over here is different, so I'm going at a little slower rate as I'm increasing or getting further away, and then as I'm getting closer to something, maybe home or something like that, I'm getting closer faster than what I was when I was going away from that place. Let's begin by writing or describing a story. So in this story, Susie took the Metro Rail to go shopping downtown with friends on Sunday. Use the graph to describe her shopping trip. In this example, we have time on our x-axis, which is hours, and our y-axis is talking about distance. For the majority of our stories, we're going to have time on our x-axis. It's not always going to talk about time, but most of them do. When we're talking about something that we're doing or something happening, there's usually a time involved. And hopefully you've noticed that all of our slopes and all of our graphs that we've done that have a real life application to it is usually per hour, per second, per minute. A lot of it has to do with time for the x-axis. Our y-axis is not always going to be about distance. It could be maybe height of something or amount of something, but in this case we're going to be looking at distance, specifically blocks from the station. So let's look at each individual part, and I'm going to kind of number them as I go along so that we can keep track of it. So let's see here, the first part right here, number 1. We can notice that Susie is going to start at 0, 0, so that means at 0 time, she's 0 blocks away from the station, and then she starts walking away from the station and reaches 4 blocks away from the station. So basically we can say that she walks 4 blocks per, and then that would be 15 minutes because that's a quarter of an hour. So she's walking at a rate of 4 blocks per 15 minutes. And then she stops. So Susie walks away from the station at a steady rate or a constant rate. We were able to find the slope of that. It was at the same incline the entire way. And we could be specific in this case since we do actually have units of measure on the x and the y-axis. Constant rate of 4 blocks per 15 minutes or quarter of an hour. So what happens next? Well, if we look right here, she stays at 4 blocks for quite a while. 2 15-minute chunks, so that would be a half an hour that she stays there. Well, why would she stay 4 blocks away? Well, she's shopping with her friends, so it's likely because she has gone into a store and she is shopping there. So in step number 2, Susie stopped at a store for 30 minutes. And then we're going to keep going from there. So now again, the next spot, she is walking away from the station again, maybe walking to another store. She doesn't walk quite as far. This time she only walks 2 blocks per 15 minutes. So it takes her 15 minutes to walk 2 blocks. So she's not going quite as fast as she was here. You should notice that this is a steeper incline than this one right here. Susie walks slower to the next door. And then at this spot right there, again, she's staying at a store, this time not as long as last time. For this time it's only 15 minutes. And then now our graph is going back down. Well, what would happen if it's going back down? Well, now she's getting closer to the station. Let's see here. She walks 1, 2, 3, 4 blocks for 15 minutes again. She walks back towards the station. And then here, she's going to stop again for another 15 minutes. And then, let's see here, then she goes back to where it almost looks like she went back to that first store. So maybe we'll say that she goes back to the first store because she forgot her coat. And then we have just a couple more left. Here, she's looking for her coat. And then in our last one right there, what is she going to do? She's walking back to the station so she could get back on the metro rail. See here, I missed a couple numbers in here. So this would be 6. 7, she walks back. 8, she looked for her coat. And then went back to the station. So this was a pretty big graph. There was a lot going on. We got pretty detailed in it, but it was a good way to see everything that was going on in that graph and kind of learn some different aspects of a graph. Now let's make a graph. In this problem, it says a soapbox derby car picks up speed at a constant rate as it travels downhill. It continues to pick up speed until the racer applies the brakes after crossing the finish line. Once the brakes are applied, the car decreases speed at a constant rate until it stops completely. Okay, so we're talking about a soapbox derby car, probably not going too fast, but still when I'm thinking speed, I'm thinking about miles per hour. Remember, this is our slope, change in y over change in x. So that can help me decide what my graph is going to look like. So my x-axis is going to be in hours, and my y-axis is going to be in miles. So now just because I pick hours and miles doesn't mean that I'm going a long time or I'm going a long distance. Like that last example, it was kind of broken up in 15-minute increments. It could be even like right at the end here could technically be 1 hour or even a half an hour. So I don't have to be specific on my x and my y axis. I just need to have it labeled and have an idea of what's going on in this situation. So as I'm walking through it, it says at a constant rate as it travels downhill. And it continues to pick up speed until the racer applies the brakes. So I'm going to start out at 0, 0 because I'm going to be starting at that start line, I guess. And then I'm going to continue to pick up a pace. And since I'm going downhill, I'm probably picking up my pace pretty quickly. So I'm going to make it pretty steep. And then I'm going to hit the brakes. Well, what happens when I hit the brakes? I still decrease speed at a constant rate, but hopefully my brakes are working pretty good, and I'm decreasing at that speed at a quicker constant rate or faster constant rate than what I was speeding up at. So my slope of my line needs to be steeper, so it'll be a little bit more straight down than what it was when I was increasing speed.